Look at part 1 for a description of the setup and all the details before you continue to look at this. Here is transmission and impedance of the 6-port Wilkinson splitter. As you can see, attenuation on 7.2 MHz is 8 decibels. While at 14 MHz it's 21, and at medium wave 1.5 MHz it is 1.3 it says. Marker 3. 1.5 MHz I have 10.5 dB attenuation. So in the measurements I did, the medium wave were attenuated by about 2 decibels as compared to 7 MHz, and frequencies above here, something above 12 MHz were severely attenuated, so they didn't go into this measurements I did before. And here is isolation between ports. It's more than 40 dB on 7.2 MHz, but 17 or 18 dB at 1.5 or 10 MHz. Isolation is only important on 7.2 because that's where I'm listening with the different radios and want to avoid interference that is being sent out by other ones that may be causing intermodulation that comes out from the antenna connector. This is a resistive 7-port splitter. It has 16.2 decibels of attenuation between any two ports, and the response is completely flat, and the impedance is very close to 50 ohms on all the frequencies. So to use this I need more power, about 8 decibels more than I've had previously. Maybe not quite, because for medium waves I had a little bit bigger attenuation than those 8 that I had at 7.2. So I will try to improve amplifier and use the resistive splitter instead. Here are the changes I made as compared to the original setup. In the first place, 3 decibels more attenuation in front of the Airspy HF Discovery, now that I have a regular production unit rather than a pre-production one, which was something not quite right with it. And I have replaced the 6-port Wilkinson with the 7-port resistive splitter. Now, after having done that, I no longer need this 6 dB attenuator, because the isolation of the resistive splitter is more or less independent of the source impedance. The Wilkinson needs a 50 ohm source impedance, but the resistive one does not. I've also removed the 3 dB attenuator at the input of the notch, which means that this amplifier will see a very unpleasant impedance on 7.2 MHz, or whatever the frequency will be of the notch, because I'm going to put other notches in here later on. So I will have to watch out that there are no very strong signals on the notch frequency when going on. And also I have to measure these receivers in the proper order. the worst one first and then replace that one with a dummy load before I go to the next one. So with the resistive splitter, measurements are more complicated, but they should be as accurate as before if done properly. I also had to increase the attenuation here in front of the spectrum analyzer to make it show the same signal level as what goes into the receivers. One note is that it no longer is correct on the notch frequency. It differs by 1 dB, and that is because the impedance here is the output impedance of the crystal filter, which is very far from 50 ohms. So the coupler couples differently by 1 dB. And the same will be for this, where I send the signal into the receivers, but I do it on a fixed frequency, so it is the same injection for all the receivers. But I had to increase the level of this generator by something like 9 dB, I don't remember exactly. Here is the Perseus. With the new settings I have 0 on the signal to noise scale, and that is with a different setting on the signal generator. But there are no antenna signals now. And here is the SDRplay. I haven't changed anything, and it comes at signal to noise ratio 0 as expected. And here is the Airspy plus Spyverter, and it also comes at 0. I just show that nothing has happened to the reference levels. And here is the Airspy Discovery, and it is half a dB down, just as it was before. I don't have half a dB attenuators, and this is such a small difference that I don't worry about it. So away with that. And here is the Net AFEDRI. And it also comes at the right place. And finally, the Airspy Dual, and it looks like this. So all the receivers have the same noise figure at the output of the combiner. Now I have added antenna signals and selected the Airspy plus Spyverter, and you can see the loss is, well, 2 dB, I want 3, so I add more antenna signal. Now the loss with the Airspy Spyverter is about 3 dB. So I stop that and switch on the SDRplay, the RSP1. And as you can see, it is very similar. It's the same setting on the attenuator. And it is, focus, it is 33 dB here. And I switch off that and switch on the Net AFEDRI. And it shows much less interference. So I take a note that the Airspy plus Spyverter as well as the SDRplay are at 33 dB attenuation. I have turned up the antenna signals for a 3 dB loss with the Net AFEDRI, and that is at 27 dB on the attenuator. I have replaced the Spyverter as well as the RSP1 by 50 ohm attenuators, and it seems like this has improved the situation for the net AFEDRI. I'll bring up the signal for it. And of course it varies with time, so I can go back a little. Well, I leave the AFEDRI running like this for a while. I could not detect any difference when connecting the Spyverter and the RSP1 again. But it seems I have a little bit too much signal, so I step back 1 dB and take this as the level, and it is 27. And this is the spectrum that goes into the receivers. And this time it's the true spectrum. Previously it was the frequency response of the Wilkinson splitter that I didn't take into account when displaying the spectrum analyzer. So peak surge and marker, it says 1.28 megahertz minus 37 dBm, and the HF signals are in the same order. This time we have on 6.2 minus 37 also. Here is the HF Plus Dual, and I have these settings. And as you can see, there is some intermodulation. If I change for HF threshold low instead, I lose signal to noise ratio, but the intermodulation goes down because the AGC is turning down the gain. But here I have a 7 dB loss in performance. And if I go back to high, well, it varies with time now, because now it's the intermodulation and not the reduced gain. So, which one to prefer will depend critically on the frequency distribution of interfering signals. At this time, it's better to have the threshold low. No, not really, because there is some hysteresis also. I think I have to switch off the strong signals. No. Well, things are variable. I have applied too much signal, it seems. So, a little less. And again, a little less. Here I have about 3 dB for a while. I just tried this is the high threshold, and now it's the low threshold. So, and again, high threshold. So high threshold is to prefer right now, but it could vary. Anyway, the attenuator now is 20 dB and 0. Here is the HF Plus Discovery with the high HF threshold and AGC, of course. I have a 3 dB loss of signal to noise ratio here, and the attenuator is on 10 to 12 dB. Here is the Perseus. I bring up the signal now by 2 dB, and you can see it goes into saturation occasionally, and sometimes severely. And that looks like this on the S signal to noise ratio. So I have to go back 2 dB, like this, to keep it from saturating seldomly only. It's like this now. And like here. And the attenuator setting now is 5 dB and 0. And here is what goes into the Perseus. Peak search and marker. It is minus 10, minus 8 dB on the medium waves, and oops, should have pressed marker and look at some shortwave. Minus 10 dB on, oh, this was the medium wave, and shortwave is here. Minus 20, or here it was minus 16 or something, 3.9 megahertz. And of course it goes up and down. This is the Perseus, and at this point in time I have reconnected the Spyverter. This is the Airspy with the Spyverter. It is the one with the lowest dynamic range, the same as the RSP1. I had to set 33 dB. I still have to set 33 dB. This is now a couple of hours later, and I have roughly 3 dB attenuation, degradation of the signal to noise. So I attenuate the antenna signal by 10 dB. And now the loss is small, in the order of half a dB, but the noise floor is fairly significant. It means I can attenuate a little bit more without losing sensitivity. So this margin, the dynamic range margin, is small but adequate for the antenna I'm using now. I could attenuate, let's say, 5 dB. 1, 2, 3, 4, 5. Well, I just removed the antenna signal because I don't remember exactly where this should be. Yeah. So I go back. I have a small loss in signal to noise ratio, but the noise floor I'm looking at here is significantly below the noise floor outside the notch. Oh. This is a little bit difficult, but now the noise outside the notch is about 5 dB above the noise inside the notch. So this is about normal. There is a very small loss of sensitivity due to the strong signals, and which signals cause this I don't know, but probably it is reciprocal mixing from stations near this frequency. I am on the 40 meter band, and you can see on the Perseus there are many strong signals not very far away. Now I'm running the RSP1, and I have it at 33 dB attenuation. Cannot quite see that. 33, yes. And the loss is going up and down, but it has been below 3 dB and above. You can see it is varying. I attenuate by 10 dB. And now interference is very small. And I remove the antenna signal. And you can see that doesn't make much difference, or maybe no difference at all. So I go back. It means that this RSP1 has a little less reciprocal mixing than the Airspy Spyverter combination. The difference is not large, but it is there, so the RSP1 is to prefer as compared to the Spyverter Airspy combination. This could be different from unit to unit. It's probably a property of the tuner, at least for the Airspy, because it has a better oscillator for the Spyverter, but the Airspy itself has an R820T tuner. And I don't remember exactly what is inside the RSP1. It's a chip from Mirix, which has the up conversion and the tuner in the same chip. It's daytime now. Here is the SDRplay with weak antenna signals, and I bring them up. And here we have approximately 3 dB of loss of the signal to noise ratio. Well, maybe 1 dB more of signal from the antenna. The attenuator setting is 17 dB, and the spectrum looks like this. There is nothing on the medium waves, but there are signals up to what's this marker? 12 megahertz, 11.6. And here is the Airspy Spyverter combination, and it now looks pretty similar as the RSP1 did, but I have changed the attenuator from 17 to 15 dB. And I switch off the antenna signal to look at the reference. And as you see, it is at 0, as it should. And here is the net AFEDRI. It looks like this on the signal to noise evaluation. And sometimes degradation is too big, sometimes not very large. So I adapt this setting of the attenuator, which is 12 dB. Here is the HF Plus Dual. It looks different from the other radios because the signal level is affected from the AGC action somehow. So you can see that the signal to noise ratio looks like it goes positive by 3 dB and it goes negative by 5 dB. This is an artifact of the computation because there is a time delay between the calculation of the noise floor and of the signal level. And since the signal level changes drastically, this time shift causes a problem. But I can hear also the signal, and I judge that this is about where a 3 dB loss in copyability of some station would occur. And that is with 13 dB on the attenuator. And here is the HF Plus Discovery. And it looks like this. It has the same properties as the HF Plus Dual, it's the same chip. The difference is there is some filtering in front of the tuner chip. And I select this setting as a reasonable limit for how much antenna signals this can accept. And the attenuator setting for that is 4 dB. Finally, here is the Perseus. It saturates occasionally, but not very often. And signal to noise ratio, as you can see. But we also have the problem with the AGC turning down the gain of the system. I can turn off the AGC on this radio. Then it looks like this. Clearly better. One can hear the clicks, but they wouldn't disturb as much as when the AGC is on. The attenuator setting now is 0. And that's roughly what the Perseus can take. It looks like this again with the AGC off. The noise blanker does not help here. And here is what goes into the Perseus in this situation. So minus 20 dBm on peaks. And To compute the ranking, just taking differences here, I find that on daytime differences are smaller as compared to nighttime. So it means that the radios are bothered by the medium wave signals. That's probably the dominating drawback of this, the RSP1 and the Spyverter, and also to some extent, well, to similar extent, the AFEDRI, the net AFEDRI. And it's a little bit surprising that the HF Plus dual port doesn't differ much between day and night in relation to the Perseus.